Alright, this is my second video on radicals and rational exponents. We're actually going to look at evaluating these expressions now. So in my previous video, I kind of talked about the idea of radicals, or you'll hear me interchange and talk about roots and rational exponents. So if you haven't seen my first video, I suggest seeing that to kind of get the basics down before we jump into this one. So here's what's going on again, a quick thing. So if we're doing, the third, take 3 to the third power, that's 27. So we start with the base of 3, then we go to the exponent and we find 27. Again, we're going to kind of work our way backwards with that today, and I'm going to show you what that means. Some things we have to be careful on is in our most basic forms, these first three, we have to worry about the signs our answers have, whether it's a positive answer, a negative answer, or no solution. So what we care about is what type of root we have. So this is the third root, the fourth root, and the square root. And we care whether that root is even or odd. So since this is an odd number, this is an even number, this is an odd root, that's an even root. If it's odd, what we're going to do is, and that's the root, so if it's an odd root, what we're going to do is we're going to keep sign the same. Meaning if we start with a positive number on the inside, our answer is going to stay a positive. If we start with a negative, we're going to end with a negative. The one we have to be worried about is even roots. Even roots are going to cause us the biggest issues. So after we start with even roots, so for example, kind of sneaking ahead here, I have the fourth root of 1296. That is an even number. The 4 is an even number. So now we have to worry about a few things. The two ways this can go is if the number on the inside, so which is A, if A is positive, our answer is going to also be positive, but it can also be negative. It's going to be positive and negative. In class, I talked a little bit more about why this happens. If it's an even root, so if we have a 4, that's even, but A is negative, so that inside number is negative, then what's going to happen is we're going to end up with a no solution answer. And I've talked about that on why this happens and the explanation behind this in class. So if you need a further explanation, talk to me. So let's start off with the third root of 64. Now remember, we're kind of working backwards from exponents. So in my class, we start really basic by looking at a table. Now let me kind of explain how this table works. Is down the side here, here's all of our bases. So basically all of our different types of A we can get. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Across the top is our exponents. So we have x squared, x to the third, x to the fourth, x to the fifth. This is how you would read it. So if I want to know what 3 to the third power was, I said is 27, how you would did that in the past is you would take 3, raise it to the third power, and it's 27. This table can easily be made by hand. It's just taking each number. So 2 to the squared is 4, 2 to the third, 8, 2 to the fourth, 16, 2 to the fifth, 32. 3 squared, 3 to the third, 3 to the fourth, 3 to the fifth, get those numbers. So this table can be made. I just like using it for kids starting out so they can kind of see how it all works. So that's how we do it with exponents, is we start with our base, then we go to our exponent, and we get our answer. Since we're doing the inverse, we're actually going to start with our exponent, and we're going to work backwards to our base. So when we do exponents, we go this way. When we're doing roots and radicals, we're going backwards, and I'll show you what that means. So our first problem here, we have the third root of 64. So this is the third root, so what we're going to do is we're going to go to the x to the third column. I'm in my x to the third column, and then next thing I'm going to do is I'm going to go down until I find the number 64. Which is here. So I work my way back and I find 4. So what in the world did I just do? I basically just found out what number to the third power gives me 64. I'll say that again. What number to the third power gets me 64? That's essentially what this is asking here. Which, using this table, we found out, well, if you take 4 to the third power, you get 64, because 4 to the third power is 64. Only thing we have to worry about is, do I have a positive, negative, no solution, what's going on here? Well, since it's the third root, and 3 is odd, we keep this sign the same. So it's positive 64, so we get positive 4. So moving on, I have the fourth root of 1296. So this is the fourth root, so I need to be in the x to the fourth column. We're going to go down till we find 1296, work our way back, we find, well, if you took 6 to the fourth power, you get 1296. So when we're asking what to the fourth power is 1296, we get 6. Only thing we have to worry about is check our signs. Since this is the fourth root, we're dealing with even roots. Our number on the inside, a, is positive, so our answer needs to be positive and negative 6. Because if you take negative 6 to the fourth power, you're going to get 1296. You take positive 6 to the fourth power, you get 1296. My next one, I have the square root of negative 25. So you're going to want to go to the table. Again, it's not typically written in there because mathematically precise, we don't put that. But this is 2, so we're going to start in the x squared column, go to 25, and you figure out, oh, it's 5. But again, we need to check and make sure we have our signs right. So if it's an even root, which it is, and a is negative, because we have a negative 25 there, oh, we're supposed to get no solution. So instead of writing 5, that would be incorrect. We're going to put no solution. Now, in these most basic ones, we have to worry about our signs. When we get more complex here, where we have an exponent on the outside, any issues with the signs are taken care of. So we don't really worry about that anymore. And there's a little bit more complicated explanation there. It's something I talked about in class, so if you need that explained to you again, let me know. So we did get a little bit more complex here. I have the third root of 125 on the inside, and then on the outside I have this square. What we're going to do is I'm going to start on my inside of the parentheses, and I'm going to work my way out. So I need to figure out the third root of 125. So again, using that table, I'll start with the x to the third column, go down to 125, and I find my answer is 5. So I figured out the inside is 5, still have it in parentheses and squared. So the only thing that's left to do is figure out, well, what is 5 squared? Now, some of you might be able to do that in your head, but we do, if you want to use the table, you can. So I'm going to start with the base and take it to an exponent. So I start with my base of 5, take it to the exponent squared, and that's 25. And then for my final example, we have the fifth root of 243. So since it's the fifth root, I'm going to go to the x to the fifth column. I go down to 243 and I find the fifth root of 243 is 3. So I figured out the inside, the fifth root of 243. This 3 exponent's still holding on. So then I just need to figure out what 3 to the third power is, and 3 to the third power is 27. And that is radicals and rational exponents 2.